Hello. We are doing a discussion on binomial approximation to normal distribution. This is a supported topic. We start with the concept that there are two types of distribution: discrete and continuous. Discrete is something which is countable, and continuous is something which is measurable. So when you say discrete, right hand side, it is a case of countable distribution. Left side, a discrete distribution, is commonly dealt with binomial. We have another feature after 22 syllabus update, that was geometric. So binomial distribution is good to use in discrete distribution. How we used to write it: x is distributed binomially n comma p, where n is the sample size, p is the probability of success, and q is the probability of failure. Now we have a formula from the start of this chapter: q is equal to 1 minus p. If a sample size is large, it is difficult to apply binomial distribution because you have to use this formula again and again. Now, if a discrete sample is large, it behaves as if it is continuous. What it means? It means that sometimes the sample is too big, like a train. It consists of separate compartments, but the train travels so fast that it appears to be a continuous thing. So, what is the idea here? What is the idea here? That a discrete sample, if it is large, it can behave as a continuous sample. So in that case, binomial distribution can be shifted to normal. It means question is given on binomial, but you can solve it on normal. Remember, the parameters in binomial are n comma p, and the parameters in normal are mu comma sigma square. Binomial deals with equal sign, but normal officially deals with either less than sign or greater than sign. So this is the transformation. There is a check there is a check to make, that if you should convert the binomial as an approximation to normal or not. You have to calculate np or nq. NP should be greater than 5. NP should be greater than 5. Now remember, now just reminder, x is distributed binomially n comma p. Ex is equal to np in this chapter, and variance is sigma square npq. So x is distributed normally mu comma sigma square. Now if a sample size in binomial distribution is large, if a sample size in binomial distribution is large, it can be transformed to normal distribution. So what's the idea here? If a sample size is quite big, if a sample size is quite big in binomial, you can shift the transformation to normal. N comma p is shifted to mu comma sigma square. Now, whenever you convert a binomial distribution to normal, you need C. C is a continuity correction. It is either zero point 0.5 up or zero point 0.5 down. Now look at this. For example, x is greater than or equal to 1. X is greater than or equal to 1. So when you're dealing with x is greater than equal to 1, you write it like this: x is equal to 1, x is equal to 2, x is equal to 3. Now, when you shift it on binomial, you have to make sure that the value is either equal or greater than 1. So you make it 0.5 backward. Correction is always 0.5 plus or 0.5 minus. So you make it 0.5 backward, and it becomes x is greater than 0.5. Another continuity correction: x is greater than 4. Now it means that numbers should be, make sure that the numbers are greater than 4. When you make a continuity correction, you have to say 4.5. Why? Because now you move the number 0.5 ahead. If you say x is greater than 4.5, now it is a surety that the number is greater than 4. number is greater than 4. Look at another continuity correction. X, this one is the same. Now look at this idea. X is less than 3. If you want to make sure that a number is less than 3, you should take it less than 2.5. Then obviously it will be less than 3. Similarly, x is less than or equal to 2. Equal sign is not possible to be managed on normal. It has to be it can be managed on binomial less than or equal to 2. So px is less than 2.5. This is another continuity correction like this. Now x is less than 2. After continuity correction, you will apply the function like normal, and normal function can be applied. And whenever you are doing continuity correction, you have to deal the equal sign into inequality. Now suppose it is x is equal to 56. After continuity correction, it will become 55.5 and 56.5. This is how we deal with equal sign. Then if it is x is equal to 0, then we take it is actually minus 0.5 to zero point 0.5. Now, some continuity corrections are here. This is just like a small exercise, small in sense of solutions are very small. So this is an exercise for continuity correction. You can try these questions and some of them is fine. Now exercise 7F. An ordinary unbiased die is thrown 120 times. Using a suitable approximation, find the probability of obtaining at least 24 sixes. Sample size is 120. You want to find x is greater than or 24. So from binomial point of view, 120 is a very big sample. If you try to manage 120 manually, it will be very difficult. So you have to shift it to normal. First you check n into p. N into p is greater than 5. So binomial will convert into normal. Now P is equal to 1 upon 6 as given in the question, because it's a fair, if you see the question. So now Q is 1 minus P, it is 5 upon 6. Now you find NP. This is the formula for expectation, which is mu. Then you find NPQ, which is variance sigma square, 16.7. Then you make a continuity correction. X is greater than or equal to 20. You have to make sure it is greater than 24. So or it can equal to 24 also. So what you take 23.5 with a greater sign. Remember, equal sign cannot be accommodated in normal distribution. Now n mu comma sigma square. You write it like this: x is greater than 23.5. Then you apply the formula for standardization and you got the number 0.857 after standardization. Then you put the value greater than 23.7, now becomes 0.857. Phi means you have to search the table and the answer becomes 0.1958. Look at this working. Question number 2. State conditions on which the distribution can be approximated by a normal. The random variable x has the distribution this. Verify that the distribution can be approximated by a normal distribution. First, you have to mention the conditions. Binomial is 25, 0.38. So n comma p, we got the n, we got the p. So we multiply them. NP is 9.5. What is the condition? NP should be greater than 5, and it is. So binomial can be shifted to normal. How is shifted? We find the NP, we find the variance, and this way binomial is shifted to normal. Now there is a continuity correction. We want to deal with 15 and 19. We want to deal with 15 and 19. So what we do, it will become 14.5 and 19.5, a correction of 0.5. It's a correction of 9.5. After continuity correction, standardize the data. After continuity correction, you have to standardize the data. X minus mu upon sigma. So z is equal to 1 z is 2.060. The other one is 4.12. Now you write them in an order and you apply the rules. The value exceeds the table limit 4.12. This is a chance. So here we use calculator. Actually, it's a book case. Normally in exam, they will not give you any number which will exceed the table given. So we use calculator. Here we got 0.9997. So we make it for the value 5b minus 5a. It is 0.0197. So these are some questions. These were some questions on binomial distribution using the approximation concept with normal. Thank you.